Mr. Saller here. For yesterday, you explored or got introduced to what a mole is in chemistry. Now, why do we use moles or this unit of measurement in chemistry? Well, we know that atoms and molecules are so small, like the smallest of the small. So it is impossible to work or measure individual atoms or individual molecules. Instead, chemists work with a bunch of atoms or molecules, and those bunch of atoms or molecules is called a mole in chemistry. Now, 1 mole of stuff equals 6.02 times 10 to the 23rd. Maybe we're talking about atoms. Maybe we're talking about molecules. You can have a mole of gummy bears if you wanted. That is delicious to think about. But essentially, it's a way that we can group atoms or molecules together so that it's actually measurable, that we can actually work with. Today, we're going to show you what a mole of carbon, water, sulfur, aluminum, silicon, copper, and a mole of gas look like. We have some good stuff for y'all today, people. So let's go ahead and check out what a mole of each one of these substances look like. And to start off, we're going to look at 1 mole of carbon. Looking at 1 mole of carbon, we see it is about 12.0 grams. Same substance that might be in your mechanical pencil, y'all. Moving on, we have 1 mole of water. Now, 1 mole of water is about 18.0 grams or 18.0 milliliters. A little food coloring in there to show what 1 mole of water looks like. And moving on, we got 1 mole of aluminum. What's up, beautiful aluminum? Such a cool element. And 1 mole of aluminum is about 27.0 grams. Moving on to one of my favorite elemental substances is silicon, y'all. Silicon, such a cool shine, such a cool luster. Let's see if we can get a close up there. Oh, such a cool elemental substance. And 1 mole of silicon is about 28.0 grams. Moving on to sulfur, we got sulfur being at 32.0 grams. We got 1 mole of sulfur. And lastly, 1 mole of copper. What does this look like? There we have about 1 mole of beautiful copper metal before it oxidizes. That is the elemental form of copper. Now you'll see that each one of these substances has a different amount of grams that is associated with it. Now, is Mr. Saller just making up these values? No! We're going to use our trusted best friend of the periodic table of elements. For example, if I want to know how many grams are in 1 mole of copper, let's zoom in. Our atomic number of copper is 29, that top number. But if you look at the bottom number, that 63.5 is a measurement we call the average atomic mass. And that bottom number on the periodic table tells you how many grams of a substance are in 1 mole of that substance. Thank you so much, periodic table. Now I know what you're thinking. What about H2O? H2O has 2 elements in it. Well, if I look at hydrogen, I have 1. If I look at oxygen, I have 16. 16 plus 1 equals 18. You add up the elements in terms of their number of atoms. 1 plus 1 plus 16 equals 18 grams or 18 milliliters in the case of water. All right, now looking at the states of matter of each of these substances we just explored, they were either in the state of matter of a solid or the state of matter of a liquid. Now, what you need to know about those 2 states of matters, solids and liquids, is that their molecules or their atoms are bound together. They are attracted to one another, and that's why they're in the state of solids and liquids, because of how attracted their molecules are, or atoms, at a given temperature and pressure. But what about the state of matter of gases? Now, we are consistently submerged in an ocean of gases all the time. How do we know the maybe volume of a mole of a gas? Well, we've actually measured it where 1 mole of any gas, doesn't matter if it's carbon dioxide, oxygen, helium, has a volume, which is a measurement of the space around us, of 22.4 liters. Now, this is at a specific temperature and pressure, something that we call standard temperature and pressure. We'll get to that to another day. But what does 1 mole of gas look like, or 22.4 liters? It's about a beach ball, okay? The size of a beach ball. And when we have 1 mole of a gas fills up roughly, maybe a little larger than this beach ball, but this is about what 1 mole of gas looks like. Check back in soon. Thank you so much for watching.